Today we'll discuss CMI's Undergraduate Programs 2019 paper, and this paper again has some interesting problems. Now the first question is, for a natural number m, define phi1m to be number of divisors of m, and for k greater than or equal to 2, define phi km equals phi1 of phi k minus 1m. Say for example, phi 2 of 12 is phi 1 of 6 and it is 4. So we'll take 12, we can write 12 as 2 square into 3, then number of divisors of 12, it is 2 plus 1 and 1 plus 1, which is 6. Now we'll write phi 1 of phi 12 and this is phi 2 of 12. So here it will be phi 1 of 6, which is 3 into 2, and 3 into 2 power is 1 here. So it will be 2 into 2 and that should be 4. So this is how we'll find this phi km. Now in the question it says find the minimum k such that phi k of 2019 to the power 2019 is equal to 2. So we are given this number which is 2019 to the power 2019. Now 2019, it is not a prime number. We can write 2019 as 3 into 673. So this is 3 into 673 to the power 2019, and we can write this as 3 to the power 2019 and 673 to the power 2019. Now both these numbers 3 and 673, they are prime numbers. So now we'll write phi 1 for n. It will simply be 2019 plus 1. So there will be 2020 into, now here again it will be 2020. So we can write this as 2020 whole square. Now 2020 is 101 into 5 into 2 square whole square. So we can write this number as 101 square into 5 square into 2 to the power 4. So we'll write phi 2n. So it will be number of divisors of this phi 1n. So it will simply be 3, 3 and 5. So that should be 3 square into 5. Now we'll find number of divisors of this function. So it will be phi 3n and it will simply be 3 into 2. Now we can write phi 4n, and phi 4n here will be, now this is 1, 1 plus 1 is 2, and then 1 plus 1 is 2. So it will be 2 square, and then we can write phi 5n, and phi 5n simply will be 3, and if we write phi 6n, now the power of 3 is 1, so it will be 2. So it says the minimum value of k for which phi k to this number n is 2. So minimum value of k in this case is simply 6. So answer to this question is k equals 6. Now the second question is, let f be real valued continuous function defined on R satisfying f dash tan square theta equals cos 2 theta plus tan theta sin 2 theta, and if f dash 0 is equal to minus cos pi by 12, we need to find the value of f1. So we know that we can write this expression as f dash tan square theta, and cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta, and here it is tan theta, and sin 2 theta is 2 tan theta upon 1 plus tan square theta. So it will be 2 tan square theta upon 1 plus tan square theta. So if we'll add them, it will be 1 plus tan square theta upon 1 plus tan square theta, which is 1. So we can write f dash tan square theta is equal to 1. So now we can write this expression as, this is f dash x equals 1 when x is greater than or equal to 0, because the range of tan square theta is simply 0 to infinite including 0. Now from this expression we need to find the value of f1. If we'll integrate, we'll write this function fx as x plus c. Now there was this typo in this question paper where they have given f dash 0 equals minus cos pi by 12. But actually the question should have been f0 should be minus cos pi by 12. So we'll take this correction. Then if we'll put value of x as 0, then we'll get c as minus cos pi by 12. So in that case, we can write this function fx as x minus cos pi by 12. Now we'll need to find the value of f1. We'll simply put x as 1. Then it'll be 1 minus cos pi by 12. And that is the answer to this question number 2. Now question number 3, it says you have a piece of land close to a river running straight. So we have this river which runs straight. You are required to cut off a rectangular portion of the land with the river forming one of the sides of the rectangle. So your fence will have 3 sides to it. You only have 60 meters of fencing. The maximum area that you can enclose is. So we have this rectangular field which is to be enclosed by this fence on 3 sides. So let this length be A and let it be B. Now length of this wire is 60 meters. So that means 2A plus B, and this value is equal to 60. Now we need to maximize this area. So we'll write this area. This area will be A into B, and we can write B as 60 minus 2A. So it will be 60A minus 2A square. So now this area is a function of A. So we'll differentiate. So it will be dA upon d small a, and it should be 60 minus 4A equals 0. So from here we'll get the value of A as 15 meter. Now if we'll plot it on a number line, then this is 15, rightmost it is minus, and then it is plus. Derivative changes from plus to minus, that is it first increases and then it decreases. So that means at A equals to 15 we get a local maxima. So we get this area maximum when the value of A is 15, and if the value of A is 15, we'll get the value of B as 30. So we'll need to find maximum area. So this maximum area will be A into B. So that will be 15 into 30, and that should be 450 meters square. And that is the answer to this question number 3. Now question number 4 again is the standard sequence and series problem. We are given sum of the series, which is 1 plus 111 plus 1111 5 times, and then it goes up to 111 2k plus 1 times. Now the first thing that we'll do is, in this series we'll find number of terms. So if we look at number of ones in the series, so for the first one it is 1, for second it is 3, for third it is 5, and then for the nth one it is 2k plus 1. So we can write 2k plus 1 equals A plus n minus 1, and D here is 2. So it will be 2k equals n minus 1 into 2. So value of n is k plus 1. So in this series there are k plus 1 terms. Now in order to find this series, what we'll do is we'll multiply and divide it with 9. So we can write this as 1 upon 9, and it will be 9 plus 999 99999, and then it will be 99 and 9, and it will be 2k plus 1 of them. Now we can write this 9 as 10 minus 1. So it will be 10 minus 1. It will be 1000 minus 1. It will be 10 to the power 5 minus 1. And it will continue up to k plus 1 terms. So we can write this series as 1 by 9, and then it will be 10 plus 10 cube plus 10 to the power 5 up to k plus 1 terms, and then it will be minus 1 minus 1 minus 1 from each of these k plus 1 terms. So there will be minus k plus 1. Now this series, it is nothing but a geometric progression. So we can write sum of this GP. So it will be 1 by 9. A in this case is 10, and then R, which is 10 square to the power n. N in this case is k plus 1 minus 1 upon 10 square minus 1, and then minus k plus 1. So we'll simplify it. We'll write 1 by 9, and then this will be 10 to the power 2k plus 2 into 10. So it will be 10 to the power 2k plus 3 minus 10, and here it will be 99. So it will be minus 99k and minus 99 upon 100 minus 1, and that should be 99. So we'll get this result as 1 by 9 10 to the power 2k plus 3 minus 99k, and this is minus 10 and minus 99, so it will be minus 109 upon 99, and that is the sum of this series. Now question number 5 is, you are given an 8 cross 8 chessboard. If two distinct squares are chosen uniformly at random, find the probability that two rooks placed on these squares attack each other. We know that a rook can move either horizontally or vertically in a straight line. So we have this 8 cross 8 chessboard, and we need to find the probability that these two rooks placed, they will attack each other. Now we need to find this probability. Suppose the event is A, so we need to find probability of this event A. Now first we'll find total number of ways in which we can place two rooks on these two squares. So altogether there are 64 squares, and from these 64 squares we need to select any two squares to place these two rooks. So it can be done in 64C two ways. Now we need to find the probability that these two rooks, they'll attack each other. So we know that these two rooks, they'll attack each other if they are placed on the same horizontal file or if they are placed on the same vertical file. So we'll take this case 1 when the two rooks are on same horizontal file. So we have 8 files. So from these 8 files, we can select any one file, and it can be done in 8C1 ways. Now once we have selected any file, then on this file, if we'll select any two squares, then these two rooks, they'll be attacking each other. So from these 8, we'll need to select any two squares, and it can be done 8C2 ways. Now plus, we can also place these rooks vertically. Now we'll have to place them vertically, then we'll have to choose a vertical file. So we have 8 vertical files. So from these 8, again we'll select any one. So it is 8C1, and again on this selected file, we can place these rooks on any two squares, and it can be done 8C2 ways. Now this is 8C1, which is 8. Now 8C2 is 8 into 7 divided by 2. So it will be 28 into 2, because both the values, they'll be same, upon 64 into 63 into 2. So 8, 864, 4, 4, 14, this is 2 and 9. So the probability that these two rooks will attack each other is simply 2 by 9. Now we'll come to question number 6. Now this question number 6 is actually a very interesting problem. For how many natural numbers n is n to the power 6 plus n to the power 4 plus 1 is a square of a natural number. So what we'll do is, we'll write this n to the power 6 plus n to the power 4 plus 1 as n square, and then it will be n to the power 4 plus n square and plus 1. Now here we'll complete this perfect square. We write n square, and it will be n to the power 4 plus n square, and then plus, we'll add 1 by 4 and we'll subtract 1 by 4 and then plus 1. So we'll write this as n square, and this is a square plus b square plus 2ab. So it'll be n square plus 1 by 2 whole square, and then minus n square by 4 plus 1. So we can actually write this as n cube plus n by 2 whole square and plus 1 minus n square by 4. Now we know that if we'll take n as 1, we'll get this expression as 3, and it is not a square of a natural number. So that means this n, it has to be 2 or greater than 2. So if n is 2 or greater than 2, then 1 minus n square by 4, this value, it will be a negative number. So we can say that this n to the power 6 plus n to the power 4 plus 1 should always be less than or equal to n cube plus n by 2 whole square, because this expression will be either 0 or less than 0. So the first relation that we have established is n to the power 6 plus n to the power 4 plus 1 must be less than or equal to n cube plus n by 2 whole square. Now in this question, what we'll also do is we'll find this expression, and which is n cube plus n by 2 and minus 1 whole square. So we'll square it and we'll take this as a and minus 1 as b. Then we can write this as n cube plus n by 2 whole square plus 1 and then minus 2 n cube plus n by 2. Now this expression, it is nearly same as this expression except for the fact that here we have minus n square by 4. So what we'll do is we'll minus n square by 4 and we'll add n square by 4. Then we can write this as n to the power 6 plus n to the power 4 plus 1, and here it will be minus 2 and then it will be n cube plus n by 2. This is plus, and if we'll take minus common, there will be minus n square by 8. So we can write this expression as n cube plus n by 2 minus 1 whole square, and this is n to the power 6 plus n to the power 4 plus 1, and here we'll take n by 8 common. So we'll take n by 8 common, we'll get this as 8n square minus n and then plus 4. Now for this quadratic expression, d is less than 0. So that means this expression is always positive, and since n is greater than or equal to 2, that means this expression is always greater than 0. So n to the power 6 plus n to the power 4 plus 1 minus some positive value will always be strictly less than n to the power 6 plus n to the power 4 plus 1, and that's our second result, which is n cube plus n by 2 minus 1 whole square is less than n to the power 6 plus n to the power 4 plus 1. Now from these two results, we can say that n to the power 6 plus n to the power 4 plus 1, it is strictly greater than n cube plus n by 2 minus 1 whole square, and it is less than or equal to n cube plus n by 2 whole square. Now in between these two perfect squares, there is no other perfect square, and we have this equality sign here. So that means this expression, which is n to the power 6 plus n to the power 4 plus 1, it will be a perfect square only when it is equal to n cube plus n by 2 whole square. So we'll open this squaring, we'll get n to the power 6 plus n square by 4 and then plus n to the power 4. Now n to the power 6 will cancel, then we'll get value of n as plus or minus 2, and since we are looking for natural numbers, that means the only value of n possible in this case is n equals 2, and in this question what they are asking for is number of values of n. So there is only one value of n which is possible, so that this n to the power 6 plus n to the power 4 plus 1 is a perfect square. Now question number 7, it is sort of a puzzle. It says a broken calculator has all 10-digit keys and 2 operation keys intact. Let us call these operation keys A and B. When the calculator displays a number n, by pressing A, it changes to n plus 1, and when the calculator displays a number n, pressing B changes the display to 2n. So say for example, if the number 3 is displayed, then the keystrokes ABBA changes the display in the following steps. Now A will change it to plus 1, so it will be 4. Then B will multiply it with 2, so there will be 8. And again B will be 16. And then again A will be 17. Now it says, if we'll start with 1, we need to find the least number of keystrokes needed to get 260. Now what we'll do is, we'll first factorize this 260. So if n is 260, we can write this as 4 into 65. So we can actually write this as 2 into 2 into 65, and this is 2 into 2 into 64 plus 1, and it'll be 2 into 2, and this is from 1 we'll get 2, and then 2 into 2 is 4, 4 into 2 is 8, 8 into 2 16, 16 into 2 32, 32 into 2 64, and then plus 1. This is the least number of keystrokes to get 260 from 1. So we have to start with 1, and first we'll go from 1 to 2, we need to press A. Then from 2 we'll need to get 4, so we'll multiply it with 2, we have to press B, and then again B, and then again B, again B, and then again B. So now we have 64. We'll need to add 1 to get 65. So then we'll have to press A. So now once we have the 65, we'll need to multiply it with 2. So again it'll be B, and finally again we'll need to multiply it with 2. So again it'll be B. So one of the orders of keystrokes could be A, and then 5 times B, and then A, B, B, which makes it 9 strokes. So the least number of keystrokes that is needed to get 260 is simply 9. So answer to this question is 9. And we can achieve this result in 2 different ways. So this is one of the way, and if you try it out yourself, you'll find another way also. Now question number 8 is, let pi equals pi 1, pi 2 and pi n be a permutation of numbers 1, 2, 3 up to n, and we say pi has its first ascent at position k if pi 1 is greater than pi 2, pi 2 is greater than pi 3, and it continues up to pi k, and this pi k, it is less than pi k plus 1. Say for example in this permutation, which is 2, 1, 3, 4, now 2 is greater than 1 and 1 is less than 3. So we are getting this first ascent at position 2. So we'll need to find the number of permutations which have their first ascent at position k. So we have n permutations. So suppose we have these n positions, which is 1, 2, 3, and suppose it is k. This is k plus 1, and this is n. Now we need to find number of permutations so that its first ascent occurs at position k. So that means we have some number in this position k such that all these numbers, they occur in descending order, and then this number at k plus 1, it should be greater than number at this position k. Now the way to solve this question is, what we'll do is, we'll take k numbers and we'll arrange them in descending order, and then we'll take k plus 1 numbers and we'll arrange them in descending orders, and then from this first we'll subtract the second case, then we'll get all the numbers in which these first k numbers, they are in descending order, but this k plus 1th number, it will not be in descending order. So it simply means at k plus 1, it will be some number which is greater than number at this position k. So we are going to solve this question using exclusion. So first what we'll do is, we'll find k numbers from these given n numbers. So from these given n numbers, we can find k numbers in NC k ways. Now once we have these k numbers, we have to arrange these numbers in descending order. So we'll arrange k distinct numbers in descending order. It can be ordered in only one way. Now what about remaining n minus k numbers? So remaining n minus k numbers, they can be arranged in n minus k places in factorial n minus k ways. Now we'll consider the second case when we are selecting k plus 1 numbers. So we'll select k plus 1 numbers from these n, then it can be done in nc k plus 1. And again, if we'll arrange these k plus 1 numbers in descending order, it can be done in only one way. And then remaining n minus k minus 1 numbers, they can be arranged in n minus k minus 1 factorial. The number of permutations which have their first ascent at this position k is given by all the permutations in which these first k numbers are in ascending order, but first k plus 1 numbers are not in ascending order. Answer to this question will be this first case, and that is nck into factorial n minus k minus nck plus 1 into n minus k minus 1 factorial. And question number 9, we need to check for each statement a, b, c, d whether it is true or false. Now we are given this function f(ab), and which is defined as this limit n tends to infinite 1 by n and then log to the base e, and it is e to the power na plus e to the power nb. Now since this n is positive, this is infinity upon infinity form. So we can use L'Hopital's rule. So we can write this function f(ab) as 1 upon e to the power na plus e to the power nb into a into e to the power na plus b into e to the power nb upon derivative of n is simply 1, and this limit, which is limit n tends to infinite. So this function f(ab), it will simply be limit n tends to infinite a e to the power na plus b e to the power nb upon e to the power na plus e to the power nb. Now we'll take 3 separate cases. Case 1, if a is equal to b, in that case we can take this a out, then e to the power na plus nb will cancel. In that case we'll write f a comma b as a or maybe b, since both a and b they are equal. We'll take the second case when suppose a is less than b, then in that case we can write this function f(ab) as limit n tends to infinite, and we'll divide everything with e to the power nb. Then we can write a e to the power n a minus b plus b, and this is e to the power n a minus b plus 1. Now this a minus b, it is less than 0, and e to the power minus infinite is simply 0. In that case this expression will be 0, so we can write this f(ab) as simply b. And this third case, when a is greater than b, in that case this a comma b, it will simply be, now here we need to divide it with e to the power na, then we'll get this function as a. So we can write this function f(ab) as a when a is equal to b, this is b when a is less than b, and this is a when a is greater than b. Now for each of these 4 statements we'll need to decide whether they are true or false. Now we'll take this first one. It says f is not on 2, that is range of f is not all of R. Now we'll take this f(ab), then this f(ab) is equal to a when a is greater than b, and this is b when a is less than b, and it is equal to a when a is equal to b. So that means it takes all the values for a and b. So range of this function is actually all real numbers. So range of this function f is R, and its codomain is also R. So f is actually on 2. So f is not on 2 is incorrect. So this is false. Now second one, it says what about f(ax)? So we'll write f(ax), then f(ax) simply will be a when x is equal to a. It will be x when x is greater than a, and it will be a when a is greater than x. Now it says for every a, this function is continuous everywhere. So we look at this function. Suppose we have any point a. Now at a, value is a. When x is greater than a, this value is simply x. And when x is less than a, this is x equals to a. So this function is a continuous function. So statement B is correct. So this is false, and then second one is true. Now we look at this third function, which is fxb. fxb will be b when x is equal to b. It will be b when x is less than b, and will be x when x is greater than b. So we'll draw this. So this, suppose this is b, and here again will be b, and then we have this number x. So it is continuous but not differentiable at b. So option C is false. Now what about option D? It says we have f0x as x for all x greater than 0. So we'll take a as 0 and b as x. Then we can write f0x as 0 when x is equal to 0. This is x when x is greater than 0, and this is 0 when x is less than 0. So when x is greater than or equal to 0, we get this function as fx equals x. So that means option D is true. So answer to this question is false, true, false and true. Now in question number 10 again, we need to decide whether each of these three statements they are true or false. Now the first one is there is no continuous function f for which from 0 to 1 this integral fx into 1 minus fx dx is less than 1 by 4, and this function is defined from r to r. So what we'll do is we'll first write this fx into 1 minus fx as fx minus fx whole square. Now what we'll do is we'll add 1 by 4 and we'll subtract 1 by 4. So we can write this as 1 by 4, and then here if we'll take minus common, we can write fx minus 1 by 2 whole square. So we'll take the integral for this function, then we can write integral from 0 to 1 fx into 1 minus fx dx will be integral from 0 to 1 by 4 dx, and then minus integral from 0 to 1 fx minus 1 by 2 whole square into dx. So we can write this as integral from 0 to 1 fx 1 minus fx dx, and here it will be 1 by 4 and then minus this integral from 0 to 1 fx minus 1 by 2 whole square into dx. Now this integral is integral of a function which always lie above x-axis. So that means this integral will be a positive number, and if this integral is a positive number, then this value will always be less than or equal to 1 by 4. So this first statement that there is no continuous function f for which this is less than 1 by 4, this is obviously false. So any function which is not equal to 1 by 2 in this 0 to 1 interval will have this integral value that is less than 1 by 4. Now for option B and C, it says there is only one continuous function f for which this value is 1 by 4, and there are infinitely many continuous functions for which this integral is 1 by 4. So we clearly know that the value of this integral will be 1 by 4 when the value of this integral is 0. And the value of this integral can only be 0 if f of x equals 1 by 2 when x lies between 0 and 1. So in between 0 and 1, there is only one function, and that is this constant function fx equals 1 by 2 when the value of this integral is 1 by 4. So now which option is correct? Option B or option C? Even though it appears that there is only one function, but then this function is defined in R and not just from 0 to 1. So that means we can write any function f with some definition f1x when x is less than 0. It should be 1 by 2 when x lies between 0 and 1, and then we can take any other definition when x is greater than 1. So any function whose value is 1 by 2 between 0 and 1 will satisfy this property, that is integral from 0 to 1 fx into 1 minus fx dx will be 1 by 4. So there can be infinitely many such functions so that this integral is 1 by 4. So that means option C is correct and option B is incorrect. So it should be false, false and true. So answer to this question is false, false, true. Now we'll discuss questions in part B. Now the first question in part B is, for a natural number n, map n, the set of all functions f defined from 1 to n to 1 to n, f and g belongs to map of n, f of gx denote function in map n which sends x to f of gx. So which is standard definition of composite functions. Now this first question is, it says, if for any f which belongs to this map n, if fx is unequal to x, then show that f of f is not equal to f. We'll prove this first result by contradiction. So let f of fx is equal to fx. So we can write f of fx is equal to fx. Now in this function there will be some y which will take this value as fx. So in that case we'll write fy is equal to y. But in the question it says fx is unequal to x for all x from 1 to n. So that means this condition it is not possible. So from contradiction we can say that this f of f must not be equal to f. Now the second part it says we need to count the number of functions such that f of f is equal to f. So that means we are given that f of f is f, that is f of fx is equal to fx. That means we can write f of y must be equal to y. Now how do we count such compositions? Now clearly it is possible when there is at least one element which has its own image. That is, out of these n elements there has to be at least one element which is mapped to itself. Say for example, suppose we have these n numbers 1, 2, 3 up to n, and then 1, 2, 3 up to n, and suppose 2 is mapped to 2. Then any value of x which is mapped to 2 will always fulfill this condition, which is f of fx is equal to fx. So that means there has to be at least one element which is mapped to itself. So what we'll do is we'll find number of such mappings when exactly k elements are mapped to itself. So first we'll need to select which k elements. So from these n, we'll need to select k elements, and it can be done in n, c, k ways. Now once we have selected these k elements which are mapped to themselves, then we have remaining n minus k elements, and for these remaining n minus k elements, each of this element can be mapped to any of these k elements. That means for each of these remaining elements we have k choices. So for this one we have k choices, for the second one also we'll have k choices, and for all n minus k elements we'll have k choices. So it'll simply be nck into k to the power of n minus k. So number of functions such that f of f is equal to f when exactly k elements are mapped to itself is nck into k to the power n minus k. Now in the beginning of this question, we have already discussed that this condition is only possible when at least one element is mapped to itself. So total number of such mappings or total number of functions is given by this nck k to the power n minus k, where value of k, it starts from 1 and it goes all the way up to n. So the total number of functions such that f of f is given by this summation, which is k varies from 1 to n, nck k to the power n minus k. Question number 2, it says count the number of roots w of the equation z to the power 2019 minus 1 equals 0 over complex numbers such that mod of w plus 1 should be greater than equal to root 2 plus root 2. Now we know that z is 1 to the power 1 upon 2019. So it simply means it is 2019th root of unity. So any 2019th root of unity is of the form e to the power iota 2 pi k upon 2019. So this equation will have 2019 roots. So suppose we have this w which is e to the power iota 2 pi k and 2019. Now it says mod of w plus 1 should be greater than equal to 2 plus root 2 and whole root. We can write this w as e to the power iota 2k pi upon 2019 plus 1, and it should be greater than equal to, this is 2, and we can write root 2 as 2 cos pi by 4. Now here what we'll do is we'll take e to the power k pi upon 2019 common. So then we can write mod of e to the power iota k pi upon 2019 into e to the power iota k pi upon 2019 and then plus e to the power minus iota k pi upon 2019, and it should be greater than equal to, if we'll take 2 common, we'll get 1 plus, and we can write this as 2 cos square pi by 8 minus 1. So here 1 and 1, it will cancel. Now modulus of e to the power iota theta is simply 1, and this is e to the power iota theta plus e to the power minus iota theta. So it is cos theta plus iota sin theta plus cos theta minus iota sin theta. So its imaginary part will cancel. Then we can write this as 2 mod cos k pi upon 2019. It should be greater than equal to 2 cos pi by 8. So we'll cancel this 2 with 2. Since cos is a decreasing function, so we'll cancel cos with cos. We can write mod of k pi upon 2019. It should be less than equal to pi upon 8. So here pi and pi, it will cancel. Then we'll get this condition as, which is mod of k should be less than equal to 2019 divided by 8. Now 2019 divided by 8 is some 252.375. So this k, it will lie between minus 252.375 to 252.375. So we'll just have to count number of integral values in this interval. So number of integral values in this interval will be 2 into 252, and then we'll also have k equals 0, which is 1. So it should be 4, 0, 5 plus 1. So it is 505. So number of roots w of this equation which satisfies this inequality is 505. Now the second question, it is fairly simple. So we are given this equation which is a to the power x, and we'll write this as 2 to the power 3x plus 3 to the power 3x upon 2 to the power 2x into 3 to the power x plus 2 to the power x into 3 to the power 2x, and this is 7 by 6. We'll divide everything with 3 to the power 3x. So if we'll divide everything with 3 to the power 3x, we can write this as 2 upon 3 to the power 3x plus 1, and it'll be 2 upon 3 to the power 2x plus 2 upon 3 to the power x, and this value should be 7 by 6. Now what we'll do is we'll let 2 upon 3 to the power x as some y. So it'll be y cube plus 1 upon y square plus y, and this is 7 by 6. Now we can write this as y plus 1 and then y square minus y plus 1 and then y into y plus 1, and this is 7 by 6. So one of the solution is value of y is minus 1. Since this y is an exponential function, it cannot take a negative value. So that means value of y cannot be minus 1. So then we'll have this condition, which is 6y square minus 6y plus 6, and this is equal to 7y. So we can write this as 6y square 13y and then plus 6 equals 0. So we'll factorize, we'll write 6y square minus 9y minus 4y plus 6 equals 0. So here it will be 3y and then 2y minus 3 and then minus 2 will be 2y minus 3. So value of y is either 2 by 3 or 3 by 2. Now we'll put the value of y. So we'll put value of y as 2 by 3, then we'll get 2 by 3 to the power x as 2 by 3, in which case we'll get the value of x as 1. And if we'll take 2 by 3 to the power x as 3 by 2, so it'll simply be 2 by 3 to the power minus 1, and then value of x will be minus 1. So answer to this question is x is plus or minus 1. Now this third question is, we need to evaluate this integral, which is I, and this is from 0 to infinite 1 plus x square to the power minus m plus 1 into dx, where m is a natural number. So in this question, what we'll do is we'll let x as tan theta, then dx simply will be secant square theta d theta. We can write this integral as, now when x is 0, theta is 0. So integral from 0 to pi by 2. Now 1 plus tan square theta is secant square theta. So it will be secant square theta to the power minus m plus 1 into secant square theta d theta. So we'll write this as 0 to pi by 2. Now secant square and secant to the power minus 2 will cancel. We'll get secant to the power minus 2m theta d theta. Now reciprocal of secant theta is cos theta. So this integral is actually integral of cos function, which is from 0 to pi by 2 cos to the power 2m theta into d theta. Now this is a very standard integral in reduction formula. So we know that Wallis formula is this integral from 0 to pi by 2 sin to the power nx dx is equal to 0 to pi by 2 cos to the power nx dx, and this is equal to, now this is n minus 1, n minus 2, n minus 3, and it will continue, and this is pi by 2 when n is even, and it is 1 when n is odd. Now in this case it is an even power. So if we'll use Wallis formula, we can write Im as 2m, and it will be 2m minus 1 and then 2m minus 2, 2m minus 3, and it will continue up to 2, 1 and I0, which is pi by 2. So that is the answer to this question. Now what we'll also do is we'll try and simplify this result. So I can write this as, so we'll multiply it with 2m, 2m minus 2, and then 4 and 2 in the numerator and denominator. Then it will be 2m into 2m minus 1, 2m minus 3, and into 2, and in the denominator will be 2m, 2m minus 2, and then 4 into 2 whole square into pi by 2. Now in the numerator it is nothing but it is factorial 2m. So we can write this as factorial 2m, and then in the denominator we can take this 2 out from every expression. So it will be 2 into 2 into 2 m times. So there will be 2 to the power m, and 2 to the power m square will be 2 to the power of 2m, and then we have m, m minus 1, m minus 2, and then 3 2 1, which is nothing but factorial m. So it will be simply factorial m square into pi by 2. So answer to this question is factorial 2m upon 2 to the power 2m factorial m square into pi by 2. Now question number 4, it is a simple geometry problem. It says let ABCD be a parallelogram and let O be a point on its interior such that angle AOB plus angle DOC is 180. We need to show that angle ODC is equal to angle OBC. So first we'll draw this parallelogram. So suppose this is A, B, C and D, and then we have any point O, and then we'll join these points. So this is AO, OB, OC and OD. Now it says this angle AOB plus angle DOC, it is 180 degrees. So suppose this is angle 1 and this is angle 2, and we need to show that angle ODC, which is this angle, it is equal to angle OBC. So it should be equal to this other angle. And this question, what we'll do is we'll do some construction. So this line, it is parallel to OD, and then from B we'll draw a line which is parallel to OC. So they intersect at this point P, and this OP, it is parallel to BC. So we look at this quadrilateral OAPB. Now this angle ODC, which is this angle, it is equal to this angle which is PAB. And in the same way, this angle which is OCD is same as angle PBA. So if this is equal to angle D and it is equal to angle C, then this P is actually equal to this angle which is 2. So we have this quadrilateral in which sum of opposite angles is 180 degrees. So it simply means this quadrilateral APBO is a cyclic quadrilateral. Now we have established that this AOBP is a cyclic quadrilateral. Now in this cyclic quadrilateral, we know that these two lines, they are parallel. So these are alternate angles. So this angle, it is equal to this angle. So say this is angle 3. So this is angle 3 and this is also angle 3. We have already established that this angle is equal to this angle. Now in a cyclic quadrilateral, angle in the same segment, they are equal. So from here we can say this angle 3 is equal to angle 4. Now angle 3 is angle OBC and this angle 4 is angle ODC. So from here we can say that these two angles, they are equal. Now in question number 5 it says there are three positive real numbers x, y, z such that x square plus y square is equal to 3 square, y square plus yz plus z square is equal to 4 square, and x square plus root 3xz plus z square is equal to 5 square. Now if we look at these three values, then 3 square, 4 square and 5 square, they form a Pythagorean triplet. That means they are sides of any right angle triangle. Now if we look at the second result also, we can write this result as y square plus z square minus 4 square is equal to minus yz, and then we can write this as y square plus z square minus 4 square upon 2yz, and this is equal to minus 1 by 2, which simply looks like cosine formula. And in the same way, this third one also we can write this as x square plus z square minus 5 square upon 2xz, and this is minus root 3 by 2. So this first one, it is cos 120 degrees, and minus root 3 by 2 is cos 150 degrees. So that means all these values, they are related to some sort of triangle. So what we'll do is we'll assume a right angle triangle whose sides are 3, 4 and 5. So let this side be A, let it be B, and let this be C. Now AB is 3, BC is 4, and AC is 5. Now in a triangle whose sides are Y, Z and 4, angle is 120 degrees. So what we'll do is we'll take a point O such that we have this BO, OC, and then AC. Now it says x square plus y square equals 3. One of it should be x and other one should be y. We have x and z with 5 also. So that means this one, it should be x, it should be y, and this value should be z. Now x square plus y square is 3 square. So this angle, it is 90. Now between y and z, angle is 120 degrees. And between x and z, angle is 150 degrees. Now if we write area of this triangle ABC, so area of this triangle ABC is half base into altitude. So it will be simply half 3 into 4. And we can also write this area as area of these 3 individual triangles. So area of triangle AOB, which is 1 by 2 x into y. Now plus area of triangle BOC, LB 1 by 2 YZ, and then sine 120, and plus finally area of this triangle AOC, which is 1 by 2 XZ sine 150. So we'll get this value as 6, and it will be 1 by 2 XY. Now sine 120 is root 3 by 2. So it will be root 3 YZ by 4, and plus now sine 150 is 1 by 2. So it will be XZ by 4. Now we'll multiply everything with 4. We can write 24, and this is 2XY plus root 3 YZ and plus XZ, and this is the result that we need. So its value is simply 24. So answer to this question is 24. Now this question number 6, it is a very simple calculus question, and the first part is we'll need to differentiate this integral function in which limits are variable. We can simply differentiate this function using Newton-Leibniz formula. So we'll put upper limit, so it'll be log e to the power x into cos 4 e to the power x into derivative of upper limit, which is e to the power x, minus derivative of lower limit, which is 0. So derivative of this integral function simply will be x into e to the power x, and then cos to the power 4 e to the power x, and that is the answer to this first part. Now for the second part, it says for x greater than 0, we have defined a function capital Fx, which is integral from 1 to x t ln t dt. So we need to find where this function is increasing and where this function is decreasing, and we need to find all the local minima and maxima for this function. So we'll differentiate this function f dash x, then we can write this as x log x into derivative of x, which is 1, minus derivative of 1, which is 0. So we'll put it equals to 0 when x is greater than 0. The only root that we'll get is when log x is 0, and that is when x is equal to 1. So we'll put it on a number line. Now when x is greater than 1, this value is positive, and between 0 and 1, this value is negative. So it clearly means this function, it decreases in 0 to 1 and it increases from 1 to infinite. So this fx is decreasing in 0 to 1 and it is increasing in 1 to infinite. It first decreases and then it increases. So that means at 1 it has a local minima. So x equals to 1 is a point of local minima. Now we'll find f1. F1 will simply be from 1 to 1 t log t dt. So any integral from same limit, its value is simply 0. So this function has a local minimum at x equal to 1, and local minimum value for this function will simply be 0. And that is the answer to this question.
If you like the video, consider subscribing and sharing it with someone you know who might benefit from it. Also, the best way to navigate any topic is through a playlist. Simply go to the channel page, click playlist, and select the topic you wish to study.